Okay, Pi Day is coming up, and I thought it would be cool to do a video on, do aliens celebrate Pi Day?
I would hope so.
Okay. This is my friend Steve. I'm Matt. Okay, so Pi Day is March 14th. 3.14 is a decimal approximation to pi. But we have 10 fingers, right? So maybe that's why we write our numbers down in base 10. But there's nothing really intrinsic about base 10. Maybe the aliens we meet have 12 fingers, for example. Maybe they write things down in base 12. So if you write pi down in base 12, for example, it's 3.18 blah, 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 blah. This little subscript means base 12. So what I've done here is I've asked Mathematica to write pi down in a bunch of different bases, starting with base 2. We're familiar with base 2 from binary stuff. It's just a bunch of zeros and ones. So maybe November 0th, which doesn't exist, is Pi Day in base 0. If we write it down in base 3, could be October 1st in base 3, or March 2nd in base 4. But the point I'm trying to make is there's nothing intrinsic about the base you use to write it down. Here's base 10, we write it down as 3.1415, and it goes on. Pi is an irrational number, which means the decimal expansion goes on forever and it doesn't repeat. And we can see you get a bunch of different representations depending which base you use. So like base 9 would be March 12th, base 8 would be March 11th, base 7, March 6th, base 6, March 5th, and so on and so on. So there's actually lots of Pi days, and maybe however many fingers the aliens have, they'll celebrate it on a different day. So the other thing I wanted to talk about, though, was is pi itself intrinsic? If we have a circle here of radius r, and we want to know how long it is around the circle as the circumference equals 2 pi r. So basically, or circumference equals pi times the diameter, where the diameter is the full way across. So pi equals the circumference divided by the diameter. So this holds for any circle. If you measure how much it is around and how much it is across, that's what pi is. So there's no getting around that. So aliens will have this same property and they will have come upon pi. But now the question I want to ask is, how many degrees are in a circle? Steve, how many degrees are in a circle?
360.
360. Do you think aliens have 360 degrees in their circles?
I would imagine so, because isn't math like kind of like the universal language? It's all...
Yes, math is the universal language, but there's nothing special about 360 degrees. It's not really the most natural way to describe ways around a circle. So, like, we probably picked that because how many days are in a year?
365.
So when the Earth moves 1 day around the sun, that's approximately 1 degree. So instead of using 365 degrees, we use 360 because it has lots of factors and everything else. But the concept of 360 degrees to another intelligent race probably won't exist, and I can prove that to you mathematically or demonstrate it. So one of the most famous formulas in mathematics is this thing: e to the ix equals cosine x plus I sine of x. This is called Euler's formula right here. And this is only true when x is measured in radians. So a radian is something that when you go around a circle, instead of being 360 degrees, it's 2 pi radians. So 360 is not really natural. 2 pi radians is natural. And when you measure angles in this formula, you get this. If you measured angles in degrees, you would get this formula, which is not as elegant. You have all these extra weird factors in there. So compare this one to this one. The only natural parameterization of this formula is to use radians. And it's very easy to prove this formula. Here's your little bit of calculus. If you use Taylor's theorem and expand cosine of x and expand sine of x, you get this. You add them together and you recover this. So it's a very simple proof, but the only way you get this nice formula is when you measure angles in radians. So there's nothing special about 360 degrees. And the other cool thing that involves pi is this formula here. This is one of the most famous formulas there is. If you ask a lot of mathematicians what's their favorite formula, this is one comes up quite a bit. It says e to the pi I plus 1 equals 0. So we're using the 5 most important mathematical constants all in one equation. E, pi, I, 1, and 0. Now this is like, whoa, why is that true? But if I said this to you, 1 going in this direction plus minus 1 going in this direction equals 0, you'd be like, huh? That's not a very interesting or profound statement. But that's really all this equation is saying. If you understand what this complex exponential function is, it's just basically saying whatever argument this is, it's that much around the circle. So when you measure angles in radians, you have 1 right here in the complex plane. Say this is the complex plane where this is the imaginary axis and this is the real axis. And then if you go pi radians in this direction, this number right here is minus 1. So e to the pi I is this number here, which is minus 1. So plus 1 equals 0. So it's basically a completely obvious statement. And that's pretty much what I wanted to say about pi. Do you have any questions, Steve?
You've lost me about 10 miles back, my friend. That is, I don't even know where you get these numbers or squiggly lines from, to be honest with you. It's pretty amazing.
Okay, but if I said to you 1 plus minus 1 is 0, that's very simple,
yeah,
right?
Yeah.
So that's what this e to the this number here, pi I, is just saying how many degrees are you, well, not degrees, how many radians are you going around. So if you go half a circle around, you get minus 1. That's really what it's saying. So this is a fancy way of writing minus 1.
All right.
Thank you very much.